start. Hey, everyone. My name is Charlie. I'm the co-founder and principal of XCamp. Today, we would like to have a trial class, which means you guys spend the next 1 hour and a half with XCamp to see if you like this coding class or not. We call it trial. Before the class, I want to share some of our thinking, especially at the AI era. So everyone knows AI is coming. AI is changing our life. It's not in the future, it's now. Some of you might have been using ChatGPT to help you, or you might use other like even robots. So that's kind of a time machines can really help us. So not only help us do labor work, but also help us maybe do some mental work, intelligent work. So we call it AI, artificial intelligence. The key question is, if AI is keep advancing, how we, especially you young next generation, to adjust to this new AI era. So today here, I want to spend next 5 to 10 minutes to share some idea of mine and XCamp. First, AI will replace some jobs. Maybe even in the long term, AI will replace a lot of jobs. In some time, AI even might replace some coding jobs. Now, I think it is doing now. We got a report from Google recently. I worked in Google for 11 years. So I just left Google working on XCamp now full-time to serve your guys. Google just reported, currently about more than 25% of the coding work is doing by AI now. This also keep rising. So next question is, do we still need to learn coding? So what's the purpose of learning coding? Or maybe other jobs, like account content, even some lawyer's job, especially, organize the documents, right? Came out a report. This might be replaced or can be done by robots, by ChatGPT, or by other AI tools. So how we could handle this? Yeah, this is kind of first topic I want to bring up here, bring to all of you, also including your parents, in this real AI era. So what can we face this kind of situation? From us, the second topic is, we believe even the tools, the AI tools keep evolving, but the thinking, the critical thinking, the analytical thinking, the computing thinking, especially problem solving, problem analysis, is still the key, for us to move forward. That's also the goal of XCamp's class. We're not only teaching how to code, but more importantly, we will teach you how to think in the computing way. Also more how to think in analytical way, how to you analyze problems and how to solve problems, how to initiate the solution. Also, because you have these coding skills, you have this capability to using tools, you could understand how AI work. This can facilitate your problem solving skills. I think that's the key part, or why XCamp, teaching kids not only coding, but more importantly, we will teach you algorithms and the data structure. That's the key training for your mind, to learn this computing thinking process, problem solving process. Yeah, that's the second part I want to share with you. As XCamp, we're not only coding school, we are kind of a brain training school to train you to solve problems. But today, definitely in the next 1 hour and a half, our teacher will show you how to do some coding problem, how to use code to generate, fun figures, how to draw stuff just with a couple lines of code. That will be fun, yeah. Finally, I like to say for all of you, even more importantly, to be an independent thinker. The reason is the AI is growing so fast. I think no one can predict what will happen in 20 years, 30 years, or 50 years. Someone may think, that like the artificial general AI is coming, especially artificial super AI will coming. So if they come, maybe our whole life will be changed. The only thing you can handle the situation is you are an independent thinker. You have your own opinion, you have your own analysis skills. You can hands-on to implement your thinking, implement your goals. That's kind of another skill. We use coding, use this class as a tool to train you to think independently. In other words, if you are independent thinker, you will be proactive. You will be self-motivated. We believe that's the only way for us to adjust the new AI era, because no one can tell you what's wrong, what's right in the next 10, 20, 30 years. That's also, in XCamp, we motivate the students to solve problems even not taught in class. So we also encourage students to work together so they can encourage together. Also, they can encourage them the teamwork, also the leadership. So that's kind of 3 points I want to share with you before the class starts, because I believe this is so important. First, we are in the AI era, it's coming. So we need to face that. Secondly, we need to focus on the capabilities on computing, thinking, problem solving. Finally, hope all of you can be an independent thinker to think your future, to adapt to this keep changing world. Today, we are very happy to have Brandon here to be our teacher. He's one of our kind of first group of teachers. He has spent, I think, almost 5 years with XCamp. He's also one of the most student-loved teacher here. Feel free, to learn. Also, feel free to answer questions by raising hands. We unmute all of you to make this class more efficient. So if you have any questions, please raise your hands. So we will unmute you, and also you can type your questions in the chat too. Okay, great. So students, parents, I'm so glad you joined this trial class. Hopefully you will enjoy the next 90 minutes. I will turn this stage to Brandon.
Thank you, Charlie. Thank you for the introduction. And as Charlie mentioned, my name is Teacher Brendan. I've been teaching at XCamp since, oh wow, it's been a while. I think it's been about 6 or 7 years so far. And during my teaching at XCamp, I've taught most of the classes in XCamp, all the way from our entry-level Python classes that we have to some of our higher classes that are more focused on competitive programming. So, if you know about competitive programming or anything like that, that's not something that we'll focus on today. But I really like this entry-level Python class. It's a lot of fun, and you're going to see exactly why today. We're going to do some fun stuff today. So before we even get started with the lesson for today, I want to make sure that everyone kind of understands what we're doing and how this is going to work. So the first thing is that our class is in Zoom. And so, we need to know, how does the Zoom classroom work? I take it that probably a good amount of you have been in a Zoom class before, maybe during COVID, or maybe you've had a lesson before in Zoom or had some sort of experience with it. So I just want to make sure that we all know sort of how, for example, if I ask a question, how would we say, oh, Teacher Brendan, I have the answer? And one of the cool things about Zoom is we have this hand raise feature. Oh, and yeah, look, I already have one student, Thomas, who already figured out how to raise his hand. So along the way, our class is going to be interactive, which means that I'm going to talk, I'm going to teach you some things, I'm going to ask some questions. And in those moments where I ask questions, I'll look for someone in the class who wants to speak up and help out to give us some answers. And so the way, if you want to contribute and answer a question, then you just use the raise hand button in Zoom. So that's the very first thing that we're going to do before we even get started is I want to see you guys all take a moment now to find out where that button is. And I want to see everyone with their hand raised. So I know that if you would like to participate in the class today, that you are able to. So I can see you and I can call on you. Okay, nice. I see a lot of students with their hands up. I'm gotta scroll through some pages. So everyone find that hand up, raise hand emoji and click it. And that way I know that if I have a question and you would like to participate and answer, then you can. Okay, that's looking pretty good. That's looking pretty good. I think there's some people on page 2 and page 3 who don't have it up just quite yet. But if you don't have it up just quite yet, look for it. Go to the reactions button and you'll see you have some reactions that you can use. You have, for example, the raise hand button, be right back. But today we'll just use the raise hand button. So we can all lower our hands now. After this exercise, if you have your hand up, I'll assume that you have a question. So just so you know, our classes in XCamp are very interactive. It's not just me sitting here talking for 2 hours and you guys listening. That would be super boring. It would be very difficult for you guys to follow along. It's a lot of questions and discussions and practice that we do together. It's going to be a little bit harder today since we have so many students in the class. I'm not going to get to hear from everyone today, but normally I would get a chance to talk with everyone, interact with everyone, and I would be able to see everyone's code for the practice exercises and things like that. So your participation today is not mandatory. If you just want to sit there and watch, even with your camera off, that's totally okay. That's totally okay for today. I understand. But normally in XCamp, we have our camera on, and I'll call on some students. We get to know each other pretty closely, and I'll call on students, and we can interact and talk. So just so you know, that's how things typically go. Okay, great. So now that we know how to use Zoom, and specifically if we want to raise our hand, we can. I am going to share my screen, and I'm going to show you something here. So what I'm showing you right now, hopefully everyone can see my screen, is I have my browser window, and this is our learning site. So at the top in the URL, you can see that this is learn.xcamp.org. And this is what you're seeing right here. These are the slides for our class today. So we have some topics that I'm going to talk about today, and everything that I'm going to talk about today, you're going to be able to find inside of this slideshow presentation. So this is something that you're not familiar with. The students who are in XCamp understand that this is the site that they enter. They have their login account, and they can see all the slides for all the different weeks. For us, it's just one class, so there's only one row here, but we would normally have all the different files for the different weeks, along with our slides for each week, homework assignments, and any other additional materials. So everything that we do in XCamp is going to be in here, except for write our code. And so normally this is where we would submit our homework, look at our homework scores, look at the slides, and all that kind of other stuff. Now, where are we going to write our code today? So hopefully everyone's had a chance to set up the Thani IDE, and this is, I'll explain later a little bit more in detail. So this is just sort of like a beginner-friendly place where we can write some Python code, which we're going to do today. If you don't have that set up, don't worry. I have another place that you can just write some Python code online temporarily for now until you get that environment set up. But like I mentioned, this is where we're going to do all of our work today and have all of the information that you would need. So that being said, let's get started. So I'm going to change so I can see my gallery view and make sure I can see all the faces. Okay. So I'm going to make this a little bit bigger here. So just as I mentioned before, normally in our class, we'd always have the camera on. I encourage you to have your camera on today so I can see you and see that this is like a real class. If you don't feel comfortable, if your camera's not working, that's totally okay. Please be respectful with your communication. I've turned on the settings so that you can just directly chat with the hosts and co-hosts, so that the Zoom chat doesn't just turn into like a chat room. That's not the point of it. It's just meant to ask questions. Class participation, like I said, normally in XCamp class we talk back and forth. There's lots of discussion and participation. If you'd like to participate today, you're more than welcome to. However, if you feel a little bit shy and just want to sit back and watch, that's okay too. And when I call on you, I don't know everyone, right? This is brand new to me, your names and your faces. So I will use whatever is your name that you've listed in Zoom. So in Zoom, if the name that you have is not the name that you want to be called, this is your opportunity to go to your settings and change that. If not, I apologize. I only know you by the name that you have listed in the Zoom. Okay, so what are we going to learn today? We are here today to learn a little bit about coding. Charlie already talked about why should we learn to code? AI can do coding for us now. What's the point? He gave us some helpful ideas on why it's valuable. We're going to learn even more today, and specifically, we are going to learn about a programming language, and we're going to learn about a very specific one called Python. So you may or may not have heard about Python before. That's totally okay. Like I said, this is a introduction class, so there's no background knowledge that you have to have in order to participate in the class today. I will make sure that I explain everything from the very beginning. So if you already have some basic knowledge, that's awesome. You can really help me out and share with your classmates what you know. And if you don't, then that's okay. Don't worry. I will make sure to fill in the gaps. At the end, we're going to do some Python programming and learn some basics. At the end, I'm going to talk a little bit more about some stuff that we're not going to learn in our entry-level classes, but something that we work our way up into as we get into our higher level classes in XCamp, which are some exciting things like algorithms. I'm not sure if everyone's heard about that word before, algorithm. But we get to learn tons of algorithms in XCamp and how we can use these algorithms to solve some really, really interesting problems. And then also along the way, we learn about data structures. How do we use these structures that hold the data in order to model these problems that we want to solve? So yeah, let's get started right away. So what is programming or coding? So essentially, it's just this idea of giving your computer some instructions on what to do step by step. And when I say what to do step by step, I mean to give it some specific task, okay? And in the next slide, we'll talk about what are some of the tasks we can do. But sometimes I'll say programming, you might also hear coding as well, so that the two are interchangeable, but it's just this idea of we write some instructions to our computer to have it complete some specific task. And so in order to get us thinking a little bit, we have some photos here. And these are just some examples that we've come up with of where coding might exist. But I will say that there are a lot more examples outside of these 6 pictures here. So if you guys can help me out, if you can either pick one of these images from the screen and raise your hand and explain to the class, what does this specific picture have to do with coding? How is coding involved? Or if you would like to be creative and think of an example that's not from these 6, that's also fine as well. Okay, so I have Nico, can you help me out here? Do you want to explain one of the pictures here, or?
Yeah. So the bottom right one, the one with Minecraft, you can code games using Python and using other coding programs.
Yeah, can you explain that a little bit more for those who aren't familiar with the game? So
Okay.
what's that idea about? What do you mean you can use coding in it?
So you use coding so that you can so that you can program the computer to make the game. Is that?
What do you mean by make the game?
Oh, you put codes and then you use that to make the game.
Like little worlds, right, in the game?
Yeah. Mhm.
Yeah. Yeah, that's right. So I've never played it, but from what my students tell me and from what I know, it's creative in that way, in that you can create these different worlds and you can use programming in order to create that. So if you have any interest at all in gaming or games in general, programming is so foundational. And actually, what we're going to learn today is kind of the very first building block of getting our way into like building these graphics, which we can put together, interacting with the user through the keyboard or the mouse, which we get to do actually in our very first XCamp course, not today, but in our very first entry-level course, we get to do stuff like that. So that's pretty exciting. So that's a really cool one. So thank you for sharing that one. Let's go to who has their hand up next? Thomas? Can you help me out?
Yeah. So, which one do you want me to do?
Your choice, whatever you like. You can explain one of the other five, or you can come up with your own idea too.
Yeah, so basically, coding is you write when you write a program in coding, it's basically so the computer just evaluates a certain scenario and reacts depending on what kind of program you wrote, and then reacts that way. This is the case for, I think, basically the right for pictures. For example, for the drone, when you press a certain button on the controller, the program and the code in the drone tells it to move in that direction, or move higher or lower. And in a game, and this is the same case for the cars, and in a game or an app, when you press a certain button, a thing happens. That is because of coding.
That's exactly right. So I don't know if I have any students who are interested in robotics at all, or who have done any robotics like camps or competitions or things like that. But if you have, or you know anything about robotics, you understand that the hardware or the machine, the robot itself, it doesn't do anything on its own, right? It just sits there in place. We as humans need to write those instructions to say how it should move, whether it's an autonomous robot where we program some way of deciding how it should make choices on which direction to go and when. Like, for example, if it hits the wall, we need to change direction and other things. Or whether it be, like we mentioned, like a drone that has a remote, and when we press the joystick on the drone, to push it to go forward, it should go in the forward direction, right? So, you know, we need people to write programs in order to make these instructions happen so that the machines can interpret that and make sure that it follows those instructions. Okay, awesome. Rishika, can you help me out with another example?
So I wanted to explain the one with the phone.
Yes.
Because all apps on phones, on computers, on iPads, anything, they all have coding to make it do a certain thing. For example, on like messages apps, you need to put in a certain code so that it'll type the words and it'll respond and it'll instantly respond and not take like a while. And for
Absolutely.
music, and for
Yeah.
for the music app, there's also actually coding the song onto the app and coding it so that when you press the play button, it actually plays.
That's exactly right. So in that last example, right, the programmers, they need to write some instructions so that when I click on a specific song, it can take that name of the song or whatever information from it, and it can go and look up where that file is, that it can make sure that it can play that music for you. So some instructions had to be written in all these applications, whether it's the calendar, whether it's the email, the messaging, the what is this one here? This is the photo app. All these apps here, we need to write some code in order for these applications to work. If not, when we press a button, nothing would happen. Or even just seeing the display of an application, someone had to create those instructions. And even what I'm clicking around right now, we have a team of people who work on this learning website, and they create new features for us so that we can, for example, if I change the toggle the visibility, something should happen, right? Someone had to create some instructions in order for that to happen. Or for example, when we have homework in the future, someone had to have written the instructions to take your solution for your problem, send it to the judger, decide whether it passed or not, and then send back the solution, right? To decide whether you got your full points or partial points or something else. I think that the one in the top left corner is maybe not always as straightforward, but maybe does someone know about this one in the top left corner? What does chess have to do with programming? Yeah, Earl, can you help me out here? Oh, can you hear me? All the faces moved around. I can't see him anymore. I'll go to let's go to Aaron. Aaron, help me out here. What's the chess have to do with programming? Can you hear me, Aaron?
So I think it's like when you move forward, it just like kind of relates to code because you're moving like a square up, and it's like similar to like inputting the computer to go like forward.
Yeah, that's a really good start. So one thing I always think about is like oftentimes when we have the XCamp class in person, when we have the in-person classes, it's always interesting to watch the students and like what they like to do or talk about during the break time or lunchtime or things like that. And actually a lot of times what I notice is that I often have students who really like playing chess. And does anyone know chess.com and have played chess online? Yeah, so it's pretty cool. It's like this website where you can log in and create your own profile, and either you can play against other people, or you can play against like a robot, some AI. And so when you play chess online, well, code has to happen so that when you move your piece from one place to another, that it updates the screen for that. But then I think a really interesting part about that is if you're playing against a robot, how does it know where to move, right? And especially think about it this way. A lot of times you get to select like a level of difficulty, right? An easy player, a medium player, a hard player. How does it know what's the right move in order to make, especially for a specific level, right? I think those are the types of things that we don't really think about too often. But it's really, really interesting. Is it just random? I don't think so, right? I don't think it's quite random, because it probably would be really easy to win against a robot that just made random chess moves. There must be some way that the robot or the AI knows in order to make a decision that's at a specific level relative to what you selected. That's really interesting, I think. But yeah, so I guess we've taken a lot of time on this slide, so I'll just round it out by saying we have, for example, the one on the bottom left corner, which is like this. We have the Pixar animation, or just animations in general. All these sort of animated TV shows, movies, stuff like that. These are these digital moving images, right? Someone had to write some instructions to create some code, or some designer who designs these these movies has to use some software that will, handle some code in the background in order to move things around the screen and, create these animations. So there's so many examples, and we can go way beyond what we see just on these 6 examples here of where code exists in our daily lives. It's really everywhere. And so there are so many examples of, if you are interested in coding at all, there's so many places where you can go and apply it in so many different ways. So I think that this is really exciting, especially if you have multiple interests that you have besides coding. Then you can take coding and just apply it to whatever you're interested in. So I think that's probably one of the coolest things about it. Okay, let's move on to this next one here. So I mentioned that today we're going to learn about Java, and I have a slide down below that's going to talk about why. But I have some programming languages here. I'm always curious to see. I know some of you may have written some code before, or maybe tried it out, or maybe you just know about it. Does anyone want to raise their hand and say one of these programming languages that they see on the screen, or maybe one that's not on here that you want to say what you know about it? Like, oh, I tried making this type of project in Python or something like that. Okay, I got lots of hands up. Let's go to Jeremy. Jeremy, can you give me an example?
I've done most of these. So I've done Python before. I learned HTML, JavaScript, and CSS on Khan Academy. And then my mom also had me take this Java course, so I know a little about it.
What did you build with Python? I'm just curious.
Python, I built a calculator.
You built a calculator? Cool.
Yeah.
And with the JavaScript and the HTML, did you build a website or a web page or something
I
like
didn't really
that?
make a website, but I code a few games with JavaScript.
Yeah. Yeah. So we won't talk about these other ones today so much, but there's a lot of different programming languages out there. Aaron, can you help me out? Do you want to give me another example?
I've done like Terrapin logo, and then I just did like a very small amount of Lua.
Oh, okay. Uh-huh. And what'd you build? Aaron, what did you build? Can you hear me?
Yeah. I think I built we did a lot of projects when I was in like a private school for Terrapin logo.
Cool. That's awesome. Yeah, so like I said, some of you will have some experience with programming. Some of you may have no experience at all. There's none necessary. We start right from the beginning. If you do have experience and you want to join XCamp and you find today's class easy, we definitely have a higher level class that can suit you. However, if you just want to sort of work your way up from our entry level class, then that's totally normal as well. So there are lots of different programming languages out there. They have their advantages of some are maybe they're designed a little bit more in favor of solving specific types of problems. Here in XCamp, we start with Python. And like I said, I'll explain why. And then we transition over to a language called C++. So this C++ is actually a very popular language in the world of competitive programming. And it's a language that is extremely fast in order to do specific tasks. It's definitely quite challenging language to learn, but in that world and for specific purposes, it's a really powerful language, and we have a lot of control over what we can do. So we won't touch that today, but just so you know, in the future, if you do go a little bit further in XCamp, we'll eventually transition from Python over to C++. And then, Java and other things like that are super popular for, different applications, and Golang as well is a pretty trendy, popular language as well, a little bit newer language. So let's get to why are we learning Python? Why do we start with Python in XCamp? The first reason why we start with Python is because it's pretty beginner friendly, meaning that it looks a lot just like writing English sentences, more so than other languages. There's some other languages, when you look at the code, you'll see all these different like characters and all these curly braces and different syntax like style, and say, I don't even know what this does. So that that might be confusing. However, when we're writing Python code, it is going to look a lot similar to the English language, which is easier for us since that's what we know. And then also as well, it's not just because it's easy to get started with. It's used in a lot of different ways. For example, artificial intelligence. A lot of times we do AI work with Python, some data analysis and other stuff like that. So there's in my personal life, I do it for some writing some small tasks or as I call them, scripts and other things like that. So it's a really cool language for specific cases, and it's a really great starting point for us. It's going to help us to get started and not have to worry about making a lot of mistakes and figuring out what's wrong with my code. Because ultimately, when we're learning to write code, we're going to write code and we're going to look at the error message and go, what is this? Why is it giving me this error? I have no clue. So let's get started. Let's jump right into writing our very first line of Python code. So if you have installed that Thonny editor or any editor of your choice, we just open it up and we can just follow the slides, which we write print. And look how inside I have this hello world. Actually, I can just copy and paste this for us. Here, I can go here and I can do print hello world. And so when in the Thonny editor, when I hit the play button, I can see at the bottom, I have this message that appears underneath. Okay. So this is how it would look in the Thonny editor. If, for example, you do not have the Thonny editor set up and you still want to participate and go along with the course, you totally as well can use the I recommend maybe just using this Python sandbox website, and you can just type in your Python code here and hit the play button at the bottom, and it'll give you your output on the right side, this pythonsandbox.com. Like I mentioned, if you don't have anything set up. So that's how we can get started. So we click the play button, and like I mentioned, we see at the bottom, we have this message that appears here. Well, what happened, right? What happened? Oh, before I say what happened, if you're using the Thonny editor or you're using the Python sandbox or something like that, and you get stuck along the way, because we have a lot of students in the trial class today, it's a little bit challenging for me to help you guys one by one. We do have two TAs that you can send a message to, and they can help you out. But I apologize if you write me a message saying that you got stuck and I ignored it. So if you get stuck, you can just sort of watch along and follow along after, or you can message one of the teaching assistants. Okay, let's go back to the slides here. So what happened when I clicked the play button? Well, like I mentioned at the bottom here, I had this window that pops up and it gives me my message. And so with this message, we look at the code that we wrote here, and it's somewhat similar to English, and so maybe I can make some sense out of this. I start by writing this word print. Now, what does print mean? Print typically means to write. When we talk about printing things, like print a piece of paper, it's this idea of putting letters on the page or putting messages on the page. And displaying it, right? So in this case, I use some quotes here, and then inside I wrote my message, and I can even change my message here to whatever I want it to be. And when I run my code, I can see that my message appears down at the bottom in this console window here. So at the top, this box that I have at the top, this is my text file. This is where I'm writing my code, my Python code. And then when I hit the play button, some magic is going to happen behind the scenes to run my code with Python and output the answer here. So print just simply means write it to the console screen, and whatever message you put, that's what will show there. One thing I want to warn you guys about, when we're writing code, we have to be very, very precise, okay? So one thing you may notice, I'm not sure if anyone tried this, but if you try and do this without the quotes here, and I run my code here, I run my code, I get an error, trace back here, it says name error, name X is not defined. And so we're not going to get into the details too much today. However, if we want to print out a message, we want to wrap it in quotes, whether it's the single quotes or the double quotes, like this. Or else it will think Python, it's not just going to interpret and know what you want. You have to be very precise. And this portion here, which we call a string, is just this message that we pass. And Python knows that this is this grouping of characters by the quotation marks around it. And you may notice that in my editor, it changed colors to show you that it understands what it is. And then also as well, another example is if you make a spelling mistake, or maybe if I wrote print like this instead, do you see how the color changed? Look, so Python's understanding what's going on, but here it's not. And I run my code and it says, hey, name error, print is not defined. And I thought, oh, well, I wrote print, it's the same thing. This is just print with lowercase letters, and that's print with one uppercase letter. But this is an example of to really point out an obvious part, which is computers, they don't think the way that you and I think, right? They don't think in that way. If you were to write a message to me and it didn't have perfect grammar, then I would still be able to understand your idea. And here we see that Python is not able to understand, even though I'm close to the right idea. So this is one of the things that can be a little bit frustrating, especially at the beginning when we're learning to write code. You need to be very precise. And along the way, if you make a mistake and you write your code and you see some error, it's probably that you missed a small detail along the way that you need to go back and double check. So as we're learning, you just want to be super precise and make sure that you match up the spelling, the case, and make sure it looks exactly as it should. So just be careful of that. Now today, we're not going to write specifically just random lines of Python code. We're going to make this a little bit more fun and interactive. And the way that we're going to do that is we're just going to jump straight into using a Python library, okay? So we're going to use this library called Python Turtle. So I'm using the word library a lot. You might be confused. What is a library? What does that have to do at all with Python code? So traditionally, if we think about the word library, you might think about your school library or something like that. It's where we go to check out books, right? We can go and we can get some information, and we can read or borrow some things from the library and return it back. And we have that same idea with code, which is there are some people out there who write some code to help us with specific tasks that might be helpful so that we can use. And then that way we don't have to start from scratch. We can just build off of some of the functionality that someone else already built. That same idea with a library book. When you check out the book, you get to borrow that information in order to use it how you want. The same way with our code, we're going to take this Python Turtle library, and it's going to get us started a lot faster with being able to do some really cool, fun stuff. Specifically, what we're going to do today is we're going to draw some images. So if I go back to my code editor here, at the moment, I don't have any way of drawing a picture, right? So all I can do right now, if I fix my code here, if I fix my code, all I can do right now is I can print some text to the screen. Cool, right? I can write some messages and stuff like that. I want to draw. Well, how can we draw? This console window at the bottom is not a graphics window, meaning that we can't put any images down below. So that's the main reason why we're using this Python turtle library, is we're going to be able to use this graphics window where when I hit the run button, it's going to pop up this window, this new window on my screen, this graphics window. And based on the commands that I give, it's going to do some drawings. So that's what we're going to use. It's like the analogy here is about it being a library is kind of like this hammer here, right? We could technically code everything from scratch, but that would take a lot of experience and a lot of time and other stuff like that. Let's just use this library and jump straight into doing some fun stuff like drawing pictures. Okay, so we are going to copy this example here. So the first thing that I need is I need this import. So this import, what it is it's saying, I want to collect this book from the library, right? Or in this case, I want to use this Python turtle library. And then the next one is just I can make a turtle, okay? So I can make a turtle. In this case, you may notice that sometimes I leave some empty spaces. So you will go back to me and you'll say, Teacher Brendan, you said we have to be exactly precise. Empty spaces are okay. Empty lines specifically are okay in Python. And oftentimes when we have things that we're importing into our program, we like to leave a little bit of space before our main code. So I'm just going to leave it like this. This won't give an error to my code. So this line here will help me to create this, what we would call a turtle object. If it's not going to mean too much to us now for now, but essentially this line of code here is going to create this turtle, and I'm just giving it a name so I can reference it by its name. I call my turtle Ted. Okay, so I follow this code here. I'm going to ignore these things. These are just comments. These are some notes that I can write in my code. Python is not going to do anything with this. This is just for me to read. So when I click the play button, I gotta move this aside so you guys can see. I have this window that pops up here. It says Python turtle graphics, and there's a little arrow that appears in the middle here. And this arrow is actually my turtle. This is Ted. He's right here in the middle of my graphics window. I haven't done anything with my turtle yet. I haven't told it to move or go anywhere. So it's just right here. This is the starting point by default in Python turtle for where it starts out. It's this little arrow character. So what did I see? I saw this cool graphics window. This is going to be my starting point, my canvas, where I can do some drawing. So that's what we're going to do today. And this is the reason why we use the library, because if not, we would not have an ability to use that graphics window and write these really cool commands that are going to help us to draw. Now, one thing you might have noticed is that my turtle did not look like a turtle at all. Okay, so if we do want to change the shape, which totally don't have to, it's, you know, all we're going to do is do some drawing. But if you would like to, you can change the shape. There's some different options for you. I can change it to like a turtle or something like that. And here's my my turtle. Okay, so there's my turtle. You can change it, or you can just leave it by the default. Like I mentioned, we're going to be focused more on the drawing part today and not necessarily my turtle. At this point, it's totally normal to be super confused. I'm talking about turtles. What does that have to do with drawing, right? So here's how the library works. We have this graphics window, and we create a turtle. And what the turtle, or the function of the turtle, is going to do for us is it's going to move. It's going to move across the screen. And as it moves across the screen, it's going to create a line. It's going to, as it moves from one place to another, it's going to like mark down a line wherever it goes. So the whole purpose of this is for me to give some commands to my turtle to tell my turtle where to go. And as my turtle moves from one position to another, it will leave a line and create a drawing. So for example, if I take this command here and I go back and I write this line here, ted.forward 100, and I run my code, I can see, oh, it was a little fast so you couldn't see what happened, but if your window popped up to the side that you could see the turtle move towards the right of the screen here. So that's what happens when I do this ted.forward in this case. Okay, so the question that we have to ask ourselves is, so I did ted.forward, and I could do ted.backwards. Let's watch this one. Here, let's just copy and paste. I run my code, and move to the left side this time. And so what is going on here? What's what does 100 mean? And I guess the other question that's pretty interesting is not just what does 100 mean, but why does forward mean going towards the right? Why not in a different direction? So let's start with that first question here. Let's figure out what 100 means. Obviously, we haven't used Python Turtle before, except for myself. Maybe a few of you have tried it out. But do I have anyone that thinks that they have maybe a guess of what 100 could mean in this case? You want to think a little bit about like units of measurement, or, you know, computers or things like that. Okay, I see that Caitlin had her hand up first. Caitlin, can you help me out?
Maybe it's like this, how many spaces it moves.
Spaces that it moves. Yeah, I really like that idea. We want to think about how many spaces that it moves. And what I will say to you, Caitlin, is we want to think about, hold on, let me clear the drawing. We don't have to draw on the screen. And let me see if I can change the options. Okay, I can't change the option right now, but one of the TAs, can you help me to stop the annotations? Okay. Oh, maybe I need to do it right now. Okay. Thank you for clearing the screen. And yeah, please go to the annotations and oh, there, I got it. Disable annotations for others. Yeah. So in this class today, we won't have to do any annotations. If I need to draw something, I will. But like I said, normally we would be able to do that kind of stuff. But in this class, we have a lot of students, and so it's a little bit hard for me to do that one-on-one interaction to be able to do that. So, okay, so let me go back to that point that was made. The spaces, what is a space, or what are these units of measurement that we're thinking about? How much is a space? Talking about inches. I guess inches, the turtle would have gone a little bit farther. Maybe something else. Benjamin, do you want to help me out and maybe get a little bit closer to what that means?
I think it could be like pixels on the like on the graphics board.
Pixels. Yeah, I think probably a lot of us have heard this word pixel, but maybe some of us have never really thought about what it means. Can you continue up that thought and just say a little bit what a pixel is?
It's like when you just magnify your computer by a lot, you can just see little squares, and they're not actually like round squares, like they're just little squares.
Yeah, that's exactly right. They're just these little squares. And so actually, everything that you see on my screen here these are pixels, right? How they're different colors, and different places on my computer screen have different colors, right? And together they can be combined in order to trick our brain into thinking that we're seeing this smooth text or images or things like that. But like was mentioned, if we were to zoom in very close, we would see all these tiny, tiny, tiny little squares. And when we're talking about the color that we see on the screen, all this really is represented in our computer is a number in between 0 and 255. These are these RGB values or red, green, blue values, which we get to learn later in the class, but not so much today. But it's this idea that our computer can sort of remember for each tiny, tiny little square on our screen, what color should be represented at that specific location. And so I don't know if you guys have ever like maybe downloaded a photo for a school project, or maybe someone sent you an image and it was really low quality or something like that, and you zoom in and you can literally see these tiny little squares, these tiny little boxes, and that's this idea of a pixel. So yeah, that's exactly right, guys. So 100, what are we talking about when we say 100? Go forward 100 pixels. Awesome. Okay, so like I said, there's the other part that we have to ask ourselves as well, which is when Teacher Brendan did this command here, forward, when he told his turtle Ted to move forward, why was forward to the right? The people who wrote this Python turtle library, surely there was some reason that they were thinking of in order to decide that forward should be to the right. Do you have any ideas? Oh, Earl, I see that you have your hand up. Can you help me out here? Any ideas?
The turtle or your cursor, basically, if it's facing a direction, it goes forward that way.
That's exactly right. So here the front part of my turtle is the head. And so forward meant literally for the turtle, since it was already starting to face towards the right, to go forward, facing its head in that direction. That's why backwards means go literally in the opposite direction that you're facing. And even if we want to go one step further, why would they make it point going to the right to start? Why not make it point going upwards? Yes, let's go to Leo. Do you have an idea for that part?
No, my hand was just raised for the last question.
Oh, okay. I see Thomas very eagerly raising his hand. Help me out, Thomas. Help me out here.
So basically, there's a coordinate system, and that is the positive x direction, meaning that it's the default is facing the positive way, so it's right.
Yeah. Okay, so this is a good opportunity to bring out my little annotations here. So this here, we kind of can think about it in terms of a coordinate plane. So a lot of times, yeah, I would say a good amount of time in writing code, having a good math background can be really helpful. And this is one of those times when we're working with drawings or graphics, to have a background in math, and then when we talk about games and stuff like that, physics as well, these types of things can be really, really helpful. For today, we don't need to know too much. The only idea that we want to think about is that we want to think about our graphics window as this coordinate plane. And notice how our turtle started in the middle, or our origin position, right? So our 0, 0 position on our coordinate plane. And so, yes, as mentioned, as we move out in this direction to the right, this is going forward in the positive x direction. And then also, very soon, we're going to learn how to turn our turtle in different directions. We're going to use our coordinate plane and our background, our small little background that we have in geometry. to think about angles and coordinate positions and things like that. We don't need to know too much math, I promise you. Everything I'll make sure that I explain. But that's the reason behind it. So if you're curious why, oops, I should have cleared it first. Y to the right, and why does forward mean that's the reason why. Okay. All right, let's keep going here. Let's keep going. So we figured out that portion here. We talked about the pixel and how it's kind of our unit of measurement when we're talking about moving forward or backwards. Let's do something a little bit fun here, which is just drawing a bunch of pictures in black and white. It's going to get a little bit boring quickly. So let's add some color here. So even before we do our drawing, let's add some color to it. So I can change the pen color and notice how this is actually pretty similar to the way that I wrote that print function, right? That command to tell my Python program to, write some message here. And like I mentioned, this is something that we call a string, which is just some words or characters grouped together. And so when we tell our Python turtle what color we want it to be, we can put in a lot of these named colors, and these are just some of the options that we have. And there's more as well that we learn in the real XCamp class. We learned that we can enter other things like some hex code to represent the color, or RGB values to represent the color. And with that, with RGB values, these red, green, blue values, with these combinations of red, greens, and blues, we can literally make every single color that we can possibly imagine. Today, we're just going to keep it real simple, though. We're just going to, take our named colors and enter them here. So, for example, like I did, I put red, and so when I run my code here, you can see that my turtle is now outlined with that red color and drags across the screen to make a red line. So that's what's going on there, okay? So that's kind of fun, and feel free, outside of the class to explore a little bit more about colors. But that's something that we don't have too much time for today, but in our regular XCamp class, we get to talk about a little bit more. All right, we can go forwards, we can go backwards. How do we turn? If I wanted to make my turtle face upwards, right, towards the positive Y direction of my coordinate plane, how would I do that? Well, we can use degrees from math. So look at this one here. What I'm going to do is, before I move my turtle forward, I'm going to turn my turtle Ted. I'm going to turn him to the right. So I'm going to turn him right 90 degrees, and then I'm going to move him forward. So now this is a question for you guys here. Based on these two lines that I have, the right and the forward, in which direction is my turtle going to advance? North, south, east, west? What do you guys think? Yeah, Alex, do you want to help me out here? Which direction do you think?
Right, because, well, it says right.
Okay, let's give it a try. So I run my code here, and it goes in the downwards direction. So let's go back to the code and let's take a look and make sure we understand why. So this command right, all that it's doing is saying, hey, I don't want you to move to the right. I want you to turn right. And specifically, I put in this value 90. Now, in this case, 90 doesn't mean 90 pixels, turn 90 pixels. 90 means turn 90 degrees. And so when we think about our angles, our measure of angles, 90 degrees is simply just to, we can think about it in that sort of L shape, and to go into the opposite direction. So you can sort of like turn your head to the side, think about it, going towards the right. And then if we go to the right side, okay, I go to the right side, 90 degrees, that would face me towards the bottom. So I can get rid of this line here to see that. So now my turtle's facing towards the bottom. And now that my turtle turned right 90 degrees, I can move him however I want to. So for example, if I did T dot Ted dot backwards, and then 100 or 200 or something like that. And I can run my code and I can see, oh, sorry, not backwards, backward. Extra character here. There, it moved in the backwards direction, in now facing up. And if I really wanted to, if I wanted to simply instead move my turtle forward and go in that north direction, well, I could just turn my turtle to the left. I could turn him left 90 degrees, then he would be facing upwards. And then I tell Ted to go forward, and there he goes in the upwards direction. So this is pretty cool. Actually, we only know a couple of commands here, and we can move in a lot of different directions, right? We can move in diagonal directions. We can move up, down, left, and right. We can go forward. We can go backward. And so now we have a lot of pieces in order to sort of move our turtle around how we want to. So you know, there's a lot of ways that we can, like I showed you, we can change it around to move left or right and then forward or backward to get the same picture, the same idea. And that's up to you as you write your code to make those decisions based on what makes sense to you, okay? If you're a little bit unfamiliar or maybe this is slightly new to you, I have a picture on the screen here to show you how the angles work and sort of their degree of measurement. So here, facing towards the right side is 0 degrees, right? So my turtle is facing, you know, in that direction, just naturally facing towards 0 degrees. If I move left, which is to go upwards, just halfway to 90, then that would be 45 degrees. To go vertical is 90, and then so on and so forth. And we can keep going around the unit circle in order to represent all these different angles. So, you know, if I wanted to turn, for example, towards the bottom direction, there's 2 ways that I can do it. So let's remember, you know, what is Teacher Brendan talking about? If I want to go in the downwards direction, I can turn left, and I can think about my unit circle and say, okay, downwards direction would be 270 degrees. Okay, let's take a look at what that would look like. So look, Ted's facing in the downwards direction. Or there's actually another way that I showed you how to get there, which is just I can think about my angle as we rotate in the other direction, going down first. And in that case, sort of opening up in the downwards direction, 90 degrees, if I go right instead, that will do the exact same thing. So it'll do the exact same thing, and it will take my turtle and it will face him in the downwards direction. So that's what I'm talking about when I say that there's multiple ways of drawing the same picture. It's up to you to sort of decide what's simple and makes sense and is easy to you in terms of the coordinate plane and giving instructions to Python turtle, okay? So like I showed, 2 different ways of achieving the exact same thing, up to you to decide. All right, we've come across our very first exercise. So now we can move our turtle how we want to. I want you guys to show me that you were following along and can use those commands in order to draw a little picture. So we're just going to get started with this square here, okay? So use those commands that we learned, right? The forward, the left, the right, in order to create this picture. And use your judgment in order to do this picture as accurately as possible. Even you might even want to notice the ending position of my turtle, the way that it's facing and stuff like that. So we're just going to do this activity. I'm going to give you like let's take about like 3-4 minutes or so to draw this square. If you are not able to do it in 3-4 minutes, that's totally okay. That it takes some time, especially at the beginning. And probably what happened is either you forgot a command. Again, that's normal as we learn stuff. Or, for example, you made a small mistake. So this should only be a few lines of code in order to draw this square. And so hopefully it doesn't take us too long. So yeah, try this out. If you finish and you want to send me your code in private message, you totally can. I see some students have already done that. I don't know if I can respond to everyone, but I'll take a look. And if you finish before your classmates, feel free to just play around and try and draw some other images, like see if you can draw a triangle or a pentagon or other things like that. And by the way, if you were not able to set up your environment for Thani, you can still use that Python sandbox. You just need to click on mode and then turtle mode. It'll open up a new one for you. And here it already, I'm going to take out these 2 lines here. It already, does the import turtle and creates you this turtle called T. So you can use that as well. And then you can do your T dot forward 100 or however much you want to. Run your code, shows up on the right side. So like I said, didn't set up your environment. Don't panic. You can still use that Python sandbox. Just make sure to go to modes and turtle mode. Okay. All right. So I'm going to go back to oh, actually it's right here. Go back here so you can see. Let's take about 2 more minutes or so. And like I said, if you're done, feel free to send me your code. It's interesting. Most people called their turtle Ted. I have 1 or 2 students who named their turtle something else. Okay, should we review together? There's some students with their hands up. I guess maybe before we review, I'm just going to double check on you guys to see if you have some questions that I can answer really quickly. Nico, do you have a question? Anything I can help you with? No, you just had your hand up? Okay. Jeremy, question, everything good? Everything good, perfect. All right, let's get to work here. So that very first command that I did, we actually don't need to change the shape, right? We just want that arrow. That first command that I did actually gives us part of that square, right? So I run my code here and I can see, oh, forward. And my turtle's name is Ted, not T. Here, I run my code and I can see I have part of that square already. So that looks pretty good. Now I just need to, as I'm along that edge, I need to turn my turtle to then be in the position to go downwards. So like I mentioned, 2 ways of doing that. I'm going to keep it simple. I'm just going to do Ted dot right. So I'm just going to turn him in to the right side of where he's facing by 90 degrees. So let's take a look at what that looks like. Now he's facing downwards. And I'm going to just repeat that over again. So here it is. So I move to the right, I turn downwards, and then I move forward by 90 degrees. And you might notice that this is actually kind of repetitive, right? I just need to keep doing this cycle of going forward and turning by 90 and going forward and turning by 90. And if I do this enough times, right, I need to do it one more time here. If I do that one more time here, then I run my code, I can see, there, I get my picture. So take a look. Looks pretty good. Looks, even the arrows facing the same way as the picture, so that looks pretty good. So how did I do it? I moved forward, I turned right, I moved forward, I turned right, I went forward, I turned right, I went forward, and I turned right. And that's how I ended up with my square. Now, just remember that the angles of the square are 90 degrees. So, you know, that it has to be 90 degrees or it's not going to work out. If I did like 80 or something, for example, then you're going to see this is a little bit off. So just make sure that your angles are 90 degrees. And then this doesn't really matter too much. If you want to just, you know, put them all as like 200 or something like that, you know, as long as it looks the same as the picture, then we're all good. But just remember, a square has all sides of the exact same length. Okay, so how about this one? Let's get, I think that this one is a little bit more challenging. So let's give this one a try. See if we can do this one. Okay, so you're not quite sure. So maybe we would kind of do that same idea of just moving forward, and then either we can turn towards the opposite direction, or we can even just go do the backwards command to go backwards. And then we can go forward again to the middle, something like that. So I'll give you a couple minutes to try that out. See if I can do this along with you guys. If you're stuck, you can follow along with me. Okay, so hopefully you had a chance to try that out. If you're stuck, let me show you my idea of how I went about doing this. So I'm gonna make this a little smaller on the side so you can see. So here was my idea, which is we can simply, let me get out my annotation. So we can simply, the turtle's facing to the right. So I'm just gonna move him out towards this side. And then when he's stuck here, I'm going to just move him back. And actually, what I can do is I can move him back double the distance to make him end up on the other side here in order to draw the rest of this portion of the line. So that's why I did TED.forward 200 and then TED.backwards 400. And then I did forward again 200 to move him back to the origin or the middle of the screen here. Then I moved him to the left 90 degrees, and now he's facing in the upwards direction. And then I moved him forward to draw the top of this plus. And then I moved him backwards double the direction to end up at the very base here. And I was very careful to match the drawing exactly where even the arrow points in the exact same direction. I guess that's not really too important. The most important is that you draw the picture as it matches, but even I took note to the direction that the turtle was facing to finish that out. So there are a lot of ways that you could have gone about this. You could have gone any direction, north, south, east, or west first, in sort of any combination of units of measurement. As long as you create this plus shape, then that's the idea of what we were trying to do. And I think, I hope that this is not too difficult, my way of doing this to follow. It just involves one turn and a couple of forwards and backwards. So hopefully you're able to follow along with that one. So if we go back to that code for drawing a square, let me go back to that code, that first one that we had, which drew our square. One thing that you may notice about this is that this is not too challenging for a square, but let's say I said, okay, I didn't actually mean that I wanted you to draw a square. Instead, I want you to make an octagon. Or instead, I want you to make a different polygon. Let's say a heptadecagon, which is a 17-sided polygon. Or something even crazier than that, something with like 45 sides or more. How would we do that? Well, I guess what we would have to think about is that there's one part which says, I guess these number of forward commands, these all draw the little line segments, right? So if I have like a 45-sided polygon, then I would have to have 45 of these TED.forward commands. And then on top of that, I would just have to do a little math to figure out what is the angle that I need to turn each time. It's not going to be 90 degrees. So I just need to figure out that angle. And based on that angle that I need to turn, I'm going to do that many turns as well to make that polygon happen. And if you think about the code that we would have to write in order to make that happen, that's a lot of copy and paste, right? It's a lot of copy and paste, or a lot of lines that you're writing yourself. And it's starting to get really, really repetitive. Look, forward, right, forward, right, forward, right, forward, right. And, one of the things that we should, as we start to learn about programming and work with computers and understand, is that part of the reason why we let computers do these tasks for us is because computers are so good at doing this repetitive work on our behalf. And we can simply tell the computer, hey, I want you to do this set of instructions and do it this many times. And so we don't have to do the complicated work. The computer can do the complicated work. So like I mentioned before, although the computer is not good at understanding small little mistakes that we make in punctuation and other stuff like that, for other cases, for these really heavy tasks of I would have to write hundreds of lines of code for really big polygons. Actually, we don't need to do that. And one of these ways in which we can do repetitive work with our Python program, or actually in programming in general, is this idea of a loop. So right now, the way that our Python program is working is that it will just simply start from line 1. It will read what's happening on line 1, then go to 2 and 3 and 4 and 5 and 6, and so on and so forth. And once it reaches the very last line, and there's nothing more for my Python program to read, it's simply done, right? It will say, hey, you're done. This is all the code that you wrote. I completed all the tasks. Finished. In this case, though, we want to change that structure. Instead of just going and telling Python read down from the top all the way to the bottom, we are going to tell Python, I want you to repeat a specific set of instructions over again. So here's what we'll do. We'll copy this code. We'll delete our original code. And my copy and paste is, okay. So what we're doing here is we're saying to our Python program, instead of me writing these two lines, these two lines in 4 chunks, in 4 blocks, and just doing copy and paste over and over again, I want you to repeat these 2 lines, these lines on line 5 and 6, do those lines 4 times. So in this way, what I'm doing is I'm sort of skipping over that idea of just saying Python read from the top to the bottom. What Python's going to do is when it gets to line 4, it's going to say, oh, okay, you want to loop, you want to repeat this chunk of code 4 times. So when I get down to the bottom of this loop, I'm going to jump back up and do it again. And so this is a really cool way in which we can do repetitive work. And so instead of having to copy and paste and do all that work over again, I can achieve the same task by simply telling Python to repeat this specific work over again. Okay, so that's pretty cool that we can do things in that way. And it really opens up a lot of doors of our possibilities for what we can draw when we utilize these loops. So that's kind of just the very beginning of exploring the types of ideas of what we can do with Python Turtle and these drawings, or just Python in general. And there's so much more for us to explore. So for example, in today's class, we didn't even get an opportunity to, like, for example, draw non-trivial shapes. For example, if I asked you, how would we draw a circle? I don't think we have an answer at this point. I'm sure that Python Turtle has a way of doing it. Actually, I know the answer, but I think a lot of you guys probably don't know. And technically, I would say that since we know how to draw lines and we know how to turn, technically we could draw something that looks like a circle. Anyone have any ideas of what I'm talking about? Yeah, Thomas? Thomas?
So basically, since it's eventually pixels at end, you can draw a polygon with no sides, such that each side is super short and it looks like a circle.
That's right.
Yeah.
That's exactly right. So what
That's
Thomas is saying
how
is, oh, go ahead.
that's also how some mathematicians found the found the formula for the found the approximate value of pi, because they just used a polygon instead with a lot of sides.
That's right. So if you just take the polygon, you increase the number of the sides, we get closer and closer and closer, right, to the idea of creating this rounded shape.
Yeah.
Obviously, we can't create the infinite number of sides polygon, but actually with our Python Turtle, and you could totally try this out. You just need to figure out the angle that we need to turn. You could totally make a circle. But actually, there's a way in which we can make circles in Python Turtle, without having to draw a polygon that has a ton of sides to it. So there's ways that we can do that. Change the turtle speed. We technically don't know how to do that. If you're using the Python Turtle sandbox, it actually had a command already given to you to control the speed. Maybe you saw that and played around with that, but we didn't talk about that today. Change the screen color. I kept on using this white background. It's nice, it's easy for us to see, but it's a little boring, right? Maybe we'll want to change the background to a different color or something like that. At the moment, we just don't know how to do that. Pick up and put down the turtle. So at this moment, we just know how to, like, tell the turtle to move from one position to another. But let's say I wanted my drawing to not just be this continuous line. I wanted to, like, pick it up and put it down somewhere so I can, I don't know, like write letters or something like that. It's the idea of, like, the difference between writing in cursive versus just writing in print, right? You would have to, in order to make these disconnected characters, you need to be able to pick up and put down the pen. There is a way to do that. We just didn't get time to do that today. clearing the screen, filling the shape with color, animations, other stuff like that. In our XCamp class at the end, we learned cool stuff like not just animations, but like, how to be able to click on your little window and then recognize where it's clicking. And, when you click, you can have some action that happens. And that's what I was mentioning. Do you guys remember at the beginning of class, we were talking about like some of the application of what you could do with code? And that's kind of like the first steps of building a game or building a movie. All the animation is, it's just all these moving pictures put together in a way in which they look like it's continuous, right? And it looks like everything is put together and it's, real movement. And then all the game is it's literally just a movie where instead of the pictures being decided how they should happen in a specific order, the difference is that the way in which things move in the pictures is decided on how you like either press keys on the keyboard or click your mouse or other things like that. So those are some other fun things that we get to do in XCamp 100 class. Just really explore Python Turtle and then just kind of get a good foundation about some of the other things in Python in general, and just explore drawing lots of pictures and learning about programming in a way that's visual, fun, and I hope not too overwhelming. It's a nice way to sort of dip our toes in the water and do something that's fun while exploring our interests with learning how to code. Okay, before we go to some of those other topics, I just want to double check. So I see two of you guys have questions. Nico, did you have a question that I can answer?
I found out the way to make the circle.
Okay, go for it. Tell me.
It's just you just do TED dot circle and then how big you want it to be.
Yeah. So let's see. So I run my code here, and there's my circle. And I guess the piece that since we did talk about this today, I guess the piece is, what is 90, right? We'll have to think about it. What is 90? What does it mean for a circle to be 90? To guess, you probably want to think about it in terms of like geometry. How, like, is this diameter, like the pixel diameter of my circle? Is it the radius? Is it something else?
Mm-hmm.
So yeah, that's something for us to think about. Alex, did you have a question?
90 is the radius.
90 is the radius. You guys are too fast for me. Yeah, 90 is the radius. That's right. So I guess now we know how to do circles, but there are more to circles, and we won't do it today, like changing the number of line segments in my circle and changing the amount of the circle that I draw. So I guess we technically don't know everything about circles, but feel free to explore whatever you want to outside of the class, or join our class, and you can learn that in the class as well. Okay, so the last part that I want to talk to you about today is a little bit more aligned with some of our upcoming classes, not necessarily our introductory class, but sort of getting you excited and thinking about where we can go with programming, especially as we move up the levels in XCamp. So we saw about how loops can make our life really easy in order to make these complicated pictures by simply telling our code to repeat itself. But another way that we can make our lives easy is through the use of algorithms. And so maybe you've heard this word before, but I like to think about an algorithm as kind of like a recipe. I almost think about like a recipe in a cookbook, for example. Let's take, for example, how to make some chocolate chip cookies or something like that. You pick out your recipe and you read it and you go, okay, the first step is that I'm going to take my flour and I'm going to put it in the bowl. And then I'm going to get out this ingredient and I'm going to, combine that. And then I take my chocolate chips and I put it into the bowl and I'll stir it together. So the cookbook or the instructions, that's our algorithm. That's our recipe that decides how we should put together our chocolate chip cookies. Now, there are a lot of different ways that we can make chocolate chip cookies, right? There's lots of different recipes out there. And just like you know, in programming, there's a lot of different ways or a lot of different recipes, algorithms in which we can solve a similar problem with a different set of instructions. So we get to see a lot of these different algorithms or these recipes in XCamp and sort of figure out how they can solve some problems. So one of the you know, interesting problems that we get to talk about and think about different ways in which we can solve it is this idea of this maze. So if you look at the photo here, it's a picture of this character, and he's got to figure out his way. This astronaut, he's got to figure out his way, how he can get to the planet. And you know, maybe you've done something like this before on a piece of paper. You take your pencil or your pen, and you start where the character is, and you kind of like maybe eyeball where it looks like the open path is, and sort of you figure out your way that you can get all the way to the end. And maybe along the way that you get stuck and you sort of retrace your path and try something else. So imagine we wanted our computer to solve a problem like this, right? For humans, we would most of the time we just kind of just go wherever our eyes take us. But with a computer, it doesn't work that way. We would have to give it instructions on in what case should we turn left or what case should we turn right? How does it know which path to take? So if we had this question of how do we find the shortest path in the maze, you know, for a simple maze like this, it's pretty easy for us to simply look at and solve. Imagine a really, really complicated maze. It wouldn't be so easy to just do that with our eyes. We would want to, you know, figure out a way in which we can do that. So in XCamp, we learn some algorithms. We talk about things like depth first search and breadth first search are these different ways in which we can go about exploring pathways, sort of exploring either really far down in one direction, coming back and trying a different route, and sort of comparing all of our different options. Or in this case, if we were just trying to find the shortest path, we would think about this idea of trying all the different paths one at a time. Well, not one at a time, but sort of in pieces. And the first path that reaches the end is the one that's the shortest. So there's some different ways in which we can do that. Another example of you know, some algorithms is, let's say, for example, we were playing this guess the number game. Like you were thinking of a number between 1 and 100, and then I guess the number, and you get to tell me if it's higher or lower. And I want to see if I can guess this number in as few tries as possible. Well, what's the optimal solution to that? You know, let's give a use case here. Let's say, for example, in your head, you were thinking about the number 99. And then I guessed, okay, is it 0? And then you say, no, it's bigger than 0. How about, I'm sorry, 0 doesn't even count. The instructions say 1 to 100. Let's say I guess 1, and you say bigger. And I say, okay, how about 2? How about 3? How about 4? At the end, it would take me a lot of guesses in order to get to the end. Versus, let's say I started at, you know, 98 or 99, and you said to me it's bigger than that. There would be not that many options that I could then select. So there's this idea of, if we have a search space and we want to find something in a search space, and we know if our answer is wrong, that we should move to the left or the right, then an optimal solution to do that would be simply just to take our search and just cut it in half and say, okay, is your number 50? No, it's bigger or smaller, right? Then I've immediately eliminated 50 of the different options, and I can go and guess in the search space that includes from 51 all the way to 100. I've immediately eliminated a ton of options, and I can just keep on cutting the search space in half until I get closer to the answer. This idea is called binary search, and it solves so many different types of problems, way more than we can possibly think of. It's something that we'll have to explore in the future. But you know, there's lots of real life examples. For example, imagine you open a dictionary, right? I guess, you know, since we're so online, we don't really have a lot of purpose for like real physical book dictionaries anymore. But imagine you open the dictionary and you're looking for a word, right? Or you know, you would sort of like flip it open, and then you go, oh, okay, I was looking, the word starts with the letter A or B or something like that. So I know that I need to go to the right side. So you sort of flip, getting closer to that side, and you kind of flip back and forth until you get closer and closer to your answer. It's kind of that same idea. So there's a lot of real life representation of these types of algorithms and how to get as fast as we possibly can to the solution. Okay, so that's kind of talking about algorithms. Let me talk a little bit about data structures. So when we're writing our computer programs, we're working with data. We're working with like messages, like some text, or we're working with numbers and doing some math and other things like that. We often want to organize that data in ways in which that it can be used in order to help us solve different problems. And so this term data structure is something that if you continue with programming, you'll revisit a lot. And it's just the idea of organizing or storing information so it can be easily used and managed. So what does that mean? That's a little bit vague. Let me give you an example here, a real life example. Imagine, for example, you are in line to order something, like, for example, get a movie ticket. So there's a line. There's this line, or also known as a queue. And the first person in line, they get to go up to the ticket counter. And everyone else, if you are joining the line, it's expected that you go to the end. And the first person in line, they'll go to the ticket counter and they'll get their ticket. As soon as they're done, they're going to exit the line, and everyone will shift up by one position. Now, this actually is a way in which we often need to model data in real life. So for example, if you look back at this picture here, this is an example of some people who are waiting in line to order their boba tea. And there's this there's this little kiosk here at the front where they put in their order, right? So how does the computer system know when they put in the order who gets served and when, right? It's following this queue structure, this idea that the first people to put in their information are going to be served first, and then the next one will be processed and served, and so on and so forth. Obviously, maybe they're making multiple drinks at once, but the way in which the data gets added to this list of orders that they have to make is represented in this queue data structure. Another example is this stack of books. So imagine we have this stack of books. How do we add books to the pile? Well, we just simply put them at the very top. And how would we remove books? Well, we can't just pull them out, right? We would have to take off the books from the top, find the one that we want, and then we have the book. So you might be thinking about, what does that have to do with real life representation? There's actually a lot of really cool puzzles that we can solve with this data structure. And actually, this data structure can help us in order to solve this maze puzzle, which we get to talk about in the future. So that's pretty cool. So, in general, as we think about these problems, it is hard for us to sort of picture how we would get there. But these are the tools that we get to in XCamp Learn step by step along the way, in order to build up that foundation where we can think about these complex problems in ways, and we can model sort of different puzzles with our code, with our data structures, with our algorithms, with the skills that we learn with our coding. So yeah, this is something for us to look forward for in the future. And so if this is something that's even slightly interesting to you, I really encourage you to explore that, because programming is actually really, really fun. If you like puzzles, if you like to, like build things and solve puzzles and all that kind of stuff, coding can be a lot of fun. Of course, it's a little bit frustrating at times when your code is not doing what you want it to do. But as you gain more skills, the better and better you get at it, you really sort to open up your mind to the things that you can build. And it's a really cool tool. It really creates a lot of opportunity for you to, like I said, to create anything that you want to, simply just with your keyboard and your computer. So I think that's what's really cool. All right, so if you want to, we have these homework challenge problems. So normally in the class we would have some homework. So for example, give this out a try. You know how to change the pen color. See if you can draw this star, and see if you can do some loops to create some geometric shapes. This one's a little bit challenging, but think about how you can use some loops. These are just simply some different size squares. So think about how you can make a geometric shape like this using that. That's kind of extending on what we learned for today. Okay, so that's all I have for you today. I'm a little bit over the time. I hope you enjoyed the lesson. And if this was interesting at all, I hope that you think about joining XCamp. And like I mentioned, whether this was easy or hard for you today, we have the right class to fit your level. So just keep that in mind. We offer a very wide variety of classes, and they really are meant for you to, depending on where your level is, sort of slowly work your way up so that you can really build a strong foundation, especially if you do want to go very far with coding. So I hope you enjoyed the lesson. You guys were an awesome class. Thank you guys for participating. And I will now turn it over to Charlie.